lesson is on the Cartesian coordinate system. Let's begin with a story about a Frenchman, named René Descartes, who was born in the 1600s, and he had very poor health as a child. So this meant he got to spend a lot of time in bed resting. It also meant that he could engage in thinking sessions where he would just relax and think and philosophize about all sorts of things. During one of these times, he observed a fly on the ceiling, and he thought about how he would describe that fly's positioning in relation to the walls. His ideas were published and further developed by other mathematicians like Fermat. So let's take a look at what the Cartesian coordinate system looks like today. You've got two axes, the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. You also have the origin right at the center. You've got four quadrants that are created by this division: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you want to describe a position on this coordinate system, you would look at the horizontal distance first. So let's say we were going to go right 3, and then you could do the vertical distance up 4, and that would give you an ordered pair or a set of coordinates describing this big black point here as 3, 4. Remember that your x value goes first and your y value goes second. So let's take a look at some examples. One example would be to plot the following points on this graph. So let's start with the first one. We've got our 2, 1. So x is 2. So we go from the origin right 2 and positive 1 in the y-axis. So this is 2 on the x, 1 on the y. They meet together at this point right here. Let's try the next one. 0, -3. So we start at 0 and go down 3. Remember, you can pause the video, try and plot them and see if you get them. So this one is 0, -3, and this one is 2, 1. The next point is -1, 0. So -1 on the x, 0 on the y, -1 on the x, 0 on the y. You could also have decimal values, so -2.5, so -2.5 on the x, and -1.5 on the y, meeting right here. You could also have -3, 4, so -3 on the x, 4 on the y, meets right there. And one more, 0, 3, 0, 3, right there. Hopefully you got them. You could also be asked to find the coordinates of given points, so reading a graph. So let's start with one of these points here. Let's take this one right here. Alright, so to get there, your x value would be -3 and your y value would be 2, giving you coordinate point -3, 2. Let's keep going. You can just try these out and see if you get them. So this would be -1, 0, because it's not going up or down, but it's going left, 1, from the origin. And this one here is 0, 3, 1, 1, 4, 0, 3, -3, 0, -2, and -2, -3. You can imagine that if you had a whole set of ordered pairs plotted all together, it would form a graph, it would form a picture, like the ones below. And these pictures are very useful in describing various examples. This step function could actually be a graph representing prices for rentals. So let's say you were renting DVDs, and for a 1 day rental, 2 day, 3 day, 4 day, 5 day, it would cost, say, $1, $2, $3, $4. So you could read this graph, and this could represent the pricing. So day one, it still costs $1. By the end of day two, it already costs $2 until midnight, you could assume. And so on. So day four actually costs not the open circle but the dotted circle $4 on day four, all the way up to day five. Linear function or piecewise function, those could also have other applications. You could have maybe time axis here and a height axis here. So say at 2 seconds an object is 2 feet above the ground. At 3 seconds the object is 3.5 feet off the ground. So being able to read a graph based on the points that have been creating it is quite an important task. So make sure you check them out.